Hi, I am Vignesh. Now I want to explain buffer overflow attack in cryptography and network security. What is a buffer overflow attack? A buffer overflow attack occurs when a program writes more data into a buffer than it can handle, causing access data to overwrite adjacent memory locations. Attackers exploit this to alter program execution, crash systems, or execute malicious code. So this is about buffer overflow. So next topic is why it is a security threat. In cryptographic and network security systems, buffer overflow attacks can allow attackers to execute arbitrary code, bypass authentication, steal cryptographic keys, and gain other unauthorized access to systems. So that's why it is a security threat. How buffer overflow happens? I will explain in step-by-step manner. So the first step is a fixed size buffer is allocated in memory. The second step is input exceeds the buffer size. The third step is access data overrides critical memory such as return addresses. Program execution is redirected to malicious code. This is how buffer overflow happens. Now, types of buffer overflow attacks. The first one is stack-based buffer overflow attack. So the definition is a stack-based buffer overflow occurs when a program writes more data into a buffer located on the stack memory than its allocated size. The extra data overrides control information such as return address, allowing an attacker to change program execution flow. How the attack works. First step is a function allocates a fixed size buffer on the stack. User input is copied into the buffer without bounds checking. Executes data overrides. Saved frame pointer return addresses. Attacker replaces the return addresses with addresses of injected shellcode. When the function returns, execution jumps to attacker controlled code. Impact of stack-based buffer overflow in cryptography and network security. So, theft of encryption keys from memory, bypass of authentication mechanisms, remote root access on network servers, compromise of SSL servers. And the second one is heap-based buffer overflow attack. A heap-based buffer overflow occurs when data written beyond the allocated buffer in heap memory overrides adjacent dynamically allocated objects or heap management structures. How the attack works. So the first step is program allocates memory dynamically using malloc, calc, etc. User input exceeds the allocated buffer size. Overflow overrides adjacent heap objects, function pointers, virtual table pointers. Attacker manipulates program behavior during future operations. Impact of heap-based buffer overflow in cryptography and network security. Manipulation of cryptographic objects, modification of key structures, execution of malicious code during encryption, decryption, persistent compromise of long-running services. So how to prevent this? Safe memory handling, heap integrity checks, and performing modern memory allocations, and also using address randomization. By using these techniques, we can prevent the heap-based buffer overflow. Now I want to explain about buffer overflow in network security. In network applications, attackers send malformed packets to overflow buffers, allowing remote code execution or denial of service attacks. Buffer overflow in cryptography. Buffer overflows can expose secret keys, modify encryption logic, or compromise cryptographic libraries such as SSL and TLS. So the attack process, how the attack goes on. The first step is identify a vulnerable program. Determine the second step is determine buffer size. The third step is craft malicious input. The fourth step is override control data. The final step, fifth step is execute attacker control code. So how to prevent? The prevention techniques for buffer overflow. Input validation and bonus checking. Bounds checking. Use secure coding practices, stack canaries, ASLR and DEP, and using memory safe programming languages. So these are the prevention techniques. So the final conclusion is buffer overflow attacks occur when a program writes more data into a buffer than it can handle. This overflow overrides adjacent memory locations leading to memory corruption. Attackers can exploit this to change program execution flow. Stack-based overflows target return addresses and control data. Heap-based overflows corrupt dynamically allocated memory and pointers. Such attacks can expose cryptographic keys and bypass authentication. Network services are common targets due to external input handling, and languages like C and C++ are especially vulnerable. Secure coding and proper input validation are essential to prevent buffer overflow attacks.